Hello, everyone. We're from the Surgical Technologies Advancing Revolutionary Cardiology Industry, in short, STARC industry. I am a head researcher, Euisuk Yoon.
And I'm the CEO, Chanju Kwon.
Today, we'll be presenting our project, Developing Artificial Replaceable Cardiac System for Minimizing Patient Burden and Enabling Seamless Replacement of an Artificial Heart. Here's a brief overview of today's presentation. We'll go through the background and motivation behind the system, its significance, how implementation works, additional features, the challenges we face, alternative approaches, and the overall impact ARC can have on patient care. On 2035, unhealthy lifestyles, especially poor diets and irregular sleep, are expected to result in serious organ damages for many people. This has already led to a growing demand of artificial organ implants, particularly artificial hearts, to extend life expectancy. However, artificial hearts come with significant limitations. Their average lifespan is only about 3 to 5 years. They also carry risks of blood clots and require invasive procedures for repair or replacements. Even the most advanced models eventually fail. So the question is, how can we make this better for patients? Here's the idea behind ARC. We wanted to design the artificial heart with flexible components for better control and durability. This is the previous design to 10 years ago, 2025, to use the pump in between the chambers. However, with technological advancement, we were able to remove the pump structure to decrease the complexity and size. The compression of the heart is done by using a biocompatible material that compresses an electrical signal. The structure of the heart is divided to right, left ventricles and artificial vessel that have two different structures. The artificial vessels that connect vena cava or pulmonary vein to ventricle has a device to pump blood to the ventricle, while the vessel that connects ventricle to arteries have a valve that opens at certain resistance threshold. The resistance threshold is measured by strain gauges on the ventricles. Artificial vessels and blood vessels are connected using junction that is only dislodged at the specific encrypted individual signals used in the hospital. Now let's talk about why this matters. Instead of one big surgery every few years, which limits the lifespan of the patient to less than 5 years, we can replace the heart separately every 1 or 2 years. With this approach, the total lifespan of the system could be extended beyond 10 years with significantly reduced surgical stress. This modular concept is a game changer in artificial heart design.
Let's work through the implantation process. First, the patient is connected to the cardiopulmonary bypass machine. Then the sternum is opened and the damaged heart is removed. These steps are similar to traditional heart surgery so far. So now here's where ARC becomes different. We implant a heart made from a material that expands and contracts like real tissue. We connect the artificial vessels to the patient's natural blood vessels, and the balloon-like chamber is inflated to restore proper pumping function. This approach ensures better integration with the body. Beyond just pumping blood, ARC has smart features. It can automatically deliver hormones like insulin based on the patient's condition. This could be especially useful for people with diabetes or other chronic diseases. And with biosignal feedback, treatment can be adjusted in real time. Another key feature is real-time monitoring. Using embedded micro pressure sensors, we can continuously track blood flow and heart pressure. If anything goes wrong, alerts are automatically sent to the patient's smartphone or medical team. This increases safety and responsiveness. Of course, there are challenges, from finding the right materials and managing blood clots to ensuring long-term biocompatibility. Minimally invasive access, infection risk, and the need for constant monitoring also present difficulties. But ARC is designed to address these step by step. We're also exploring alternative solutions. One approach is to discard the replacing mechanism and focus more on improving the durability the arc. Another is to only integrate external drug delivery systems that work in sync with biosensors. Both aims to suggest alternative methods that properly addresses our key problems. Ultimately, the ARC system offers several major benefits. It improves long-term outcomes, reduces surgical load, and provides precise treatment through biosignal-based control. It can also be applied beyond heart failure to a broader range of patients. This makes ARC not just a device, but a platform for future biomedical innovation. Thank you so much for your attention. We hope the ARC system will contribute to the next generation of personalized and sustainable artificial organ technology.